Chapter 11 in Thermodynamics Combined Radiation and Convection Heat Transfer. A 1000 watts iron is permitted on the iron board with its base to stay revealed to the air at 20 degrees Celsius. Between the base surface and the air around it, the convection heat move coefficient is 40 watts per meter squared Kelvin. If the base has an emissivity of 0.7 and a surface area of 0.02 meters squared, determine its base temperature. Now let's analyze our given with their energy total per unit time at 1000 watts, that being iron, the temperature for our surrounding at 20 degrees Celsius, our heat transfer coefficient at 40 watts per meter squared Kelvin, our surface area at 0.02 meters squared, as well as our emissivity at 0.7. And now we're tasked to find our absolute temperature. Since it is said that it is exposed to the air, we will need to add the heat transfer from our convected heat. Now firstly, let's have our heat transfer per unit time of our radiation with the equation emissivity multiplied by our surface area and our Stefan-Boltzmann constant multiplied by the change in absolute temperature raised to 4 and our temperature of our surrounding raised to 4. So we'll have our 0.7, 0.02 meters squared, 5.67 times 10 raised to negative 8, and our missing value of T sub s raised to 4 and 293 Kelvin, or 20 plus 273 raised to 4. Simplifying that, we'll have 0.938 times 10 raised to 10, as well as our T sub s raised to 4, minus 5.85. Now for our convection, we'll have our heat transfer coefficient and our surface area, and the change in temperature in our surrounding, and our absolute temperature. So that will be 40 times 0.02 and our missing value of T sub s minus 293, or 20 plus 273 point. And simplifying that, we'll have 0.8 T minus 234.4. Inputting that into our first equation, we'll have 7.938 multiplied by 10 raised to 10 T sub s raised to 4 minus 5.85 plus 0.8 T minus 234.4, as well as our Q total of 1000 watts. And combining our like terms, that will be 1240.25 is equal to 7.938 times 10 minus raised to negative 8 T sub s raised to 4 plus 0.8 T sub s. Finding the value of our absolute temperature, that will be 899.82 Kelvin, or 626.67 degrees Celsius.